sorry, can you collapse that ribbon on the side so that the CAD part is?
Okay. Okay. So initially I created a new file, so new design. So I named it square peg. I was modeling a square peg in a circular hole kind of thing. Okay. So then I created new two components. So one is square peg and another one is circular hole. Then I started activating this square peg component. So as you can see here, and okay. So initially, so first thing I did is I did a sketch, which is okay. This is visible. Okay.
You'll have to switch on the visibility of the sketch so that we can see that.
Oh, okay. Oh, sorry. So sorry. Let me small. Sorry. Initially, I made the circular hole part thing. So first, what I did is I made a sketch. Okay, so this is a sketch I made. So what I did here is initially given the dimensions for this side, which is added here. I have given as a parameter, so I have added it in the parameter here. As you can see, everything I added is in with the respect to the parameter D1. D1 is the length of this side, the longest length of the rectangle. So that's 250 mm. And the other dimension D2 is with respect to D1. So I've added a parameter. Then I have made the circular hole at the center, which is again is a parameter with respect to D1. So everything, all the dimensions I have made in the entire model is with respect to D1. So if you change the D1, the entire model will adapt to that. So I've made that kind of thing. And I made these small holes and use the symmetry option to, I've drawn one hole and use the symmetry option to get to the other half. So this is the first thing that I did. And then I extruded this part. Here it is. So I use the extrude option, extrude option here, and I extruded to the particular height. Again, as I said, everything, the height, all the dimension were is with respect to the entire length of the rectangle. So this is the extrusion. And the next thing I did is I made a base here, and that's here. So this is the using the offset command. First, I projected this extrusion sketch and then used offset command to offset it by some distance. So that's the sketch that you can see here. Then using that, I modeled another extrusion in the opposite side. So here I did not include this center hole, only the outer part and the small 4 small holes, and I extruded it in the opposite direction for a particular distance. And then I added fillets. So as you can see, I added fillets here. And again, then I added a fillet on this top. So this is the part with respect to the circular hole, which I modeled first. I activated the circular hole and I did all these commands, use these commands and to draw this entire assembly. Then I went to the square peg hole. So in the square peg, the first thing I did is model the square. Yeah, so as you can see, this square that I have made, using the constraints, I have attached it with the circular hole, such that as the hole expands, the square will also expand to that amount. So that's what I use the constraints to do that. And then I extruded that. I extruded the square to a particular to the entire height of the hole, and that's the second command. Next, I modeled the top head. So the top head I did in the form of a hexagon type. So I modeled it with respect to the square hole. So I used the, as you can see, I have used these construction lines and used the constraints such that the hexagon part will adapt to the center square. So as the square gets bigger, the hexagon part will also get bigger. So that's the thing. And the next, I extruded that hexagon to a particular amount. Then using the fillet, as you can see, I have added the fillet inside. So see here, a fillet at this location, and then I've added chamfer at the top portion. So yeah, I've added chamfer to the top hexagonal part. Then I've added another sketch. So just to write like a company name or something, use the text option to write the name as delta, then use extruded command to extrude it to particular amount. So this is the entire thing. Then I add a chamfer to this base part also. So this is the entire work.
Thank you, Shankar. That was nice and detailed. Um, I have a few points which may be useful for others and for you as well, and you can always revise it and then upload the submission.
Yeah.
One is if you can open, I don't have an option to request control, but if you can open the tree of the square part, square
Okay.
peg, sorry. Yeah. So do you see a difference between the icons of the sketches versus the icons of the sketches in circular hole?
Yeah, it's logged here, whereas here it is not logged.
Yes. So that is because your sketch is fully constrained in the circular hole. All your sketches are fully constrained, which is why the lock is there. And in the square peg, the sketch is not fully constrained. So can you open any one of the sketches? Just activate any one sketch from the square peg.
Yes.
Yes. So as you can see, it's still blue, right?
Yes.
Yes. So I think the dimension is, yeah. See, either one of those is not fully defined, either the width or the length. Right? So that is something you need to be careful about, because since you created so many dependencies on the original dimension, if the sketches are not constrained, they will not operate as you intended. Right?
Okay.
So it's always good practice to make sure all your sketches are fully constrained. So that way, you know that the sketch will only change as you want it to change, right?
Yeah.
That is one
Yes.
comment. Second thing is in sketches, again, this is coming from the point of view of good practice, uh, which you will anyways develop over experience. This is not a comment on the work you've done, which I think has been comprehensive. Uh, in sketches, generally, it's best to avoid giving the fillets within the sketch itself, right?
Okay.
So
Okay.
yeah, so it's because in terms of manipulation later on, if you want to change the values or do anything else, you need to go back. Let's say if I want to remove the sketch now, you'll have to delete that sketch element and then join the lines again, or if the dependencies break, you'll have to give the constraints again, right? So it's in terms of the work required to do any changes, it's much more intensive when you give a fillet within the sketch, right? But if you do it with an operation, like we had discussed, then it's easier because you can add multiple fillets within the same feature, right? So can you activate any fillet feature here from your timeline below?
Yeah. This one.
Yeah, just double click on that so that the feature is just activated.
Okay.
Yeah. So you can see a plus and a cross sign, right?
Yeah.
So when you click on plus, press Control on your system.
Okay. Okay.
So you can see the edges that are already selected. Now, if you want to select more,
Okay.
click on plus, and then you can select more edges, right?
Yeah. Okay. Yeah. The point. Yeah.
Okay, so it's much more easier to do manipulate things and change things when you have a fillet that's applied as a feature rather than in the sketch, right?
Okay.
Third point, I think it's nice that you've used the parameters to define the dependencies of different dimensions. But in terms of good practice, again, the four holes on the corner, the four corners. So that is also a dependent parameter, right?
Yeah.
Yeah. So if the holes, I know it's not the case here, but if the holes are meant for a fastener, like a screw, right? Then it should not be a dependent parameter, right? Because you may change the size of the object, but you cannot give a random value to the hole size for a screw, right? Though there are standards defined for that. And we'll come to a tool that we'll look at a tool that helps you define the hole sizes based on screw dimensions or fastener dimensions that you're going to select, right? So again, that is a question of good practice, but that will come with experience as you do more and more modeling. Okay, so these were 3 points, but those that I noticed in his assignment. But these are applicable to everyone, so you can make a note of that, and when you are submitting the assignment, you can try and incorporate that. Any questions from anyone else so far, based on whatever we discussed last week and the walkthrough that Shankar gave us? Or any points, comments you found anything interesting, or you found it difficult to start it up, or any issues? Okay, fine. If not, then yeah.
Not a question from the exercise, but like the color coding done here and on your interface also, it's not showing in mine version, so it's not a problem for me. But
Yes, the color coding will come to that. There's actually an option to activate it.
Okay.
Here it is, right?
Yeah,
Color switch, right?
Yeah, component color cycling. We'll come to that. Okay, so I'll just share my screen and briefly tell you what we'll be covering today. Yeah. Is my screen visible?
Yes.
Okay. So I'm using the online version today because I'm joining this meeting from a old laptop. So it's difficult to run Fusion there. So I'm using the web version, which is sort of the advantage of Fusion, that you can also run it on lower end system.
Able to hear his voice, or is it breaking for you also, for the others also?
It is breaking.
Yeah, Deval, you may have to just stop for a minute and then continue. We lost you for the last minute or so, man. Just maybe hold for a minute and then start.
So, since last week we covered this basic command of class.
Deval, I think we are missing alternate words, Deval. You. Yes, you're not able to hear him, right? Other students?
Yes, no, sir. We are also not able to hear.
Just wait, he'll join again, then I'll just ask him to join again.
The design works.
Yeah, he's going to just disconnect and join again. Let's hope if he can, that works. Otherwise, Kidir, you are on the call. You may have to start first then, huh?
Yes, sir.
Okay, just wait. Let's see how it goes with him if he leaves and joins. Yeah.
Okay.
Thanks. Yeah.
Hello?
Yeah, we are able to hear you. So let's get started and see how it works.
Yes.
Kidir is on the call. So in case this kind of a stumble happens when I'm not around, you could just communicate with Kidir directly and he will pick it up in case you are not able to join or have difficulties.
Okay, yeah, sure.
Yes.
I have put in a new data plan, so I think it should work now.
Yeah,
Yes.
we are able to hear you. Yeah.
Okay. And the screen is visible?
And the screen is visible, yes.
Okay. Sorry, everyone. So what I was saying today, what I intend to cover is basically some more operations in the design workspace pertaining to revolve, sweep, loft, and a couple of other items. And then I would like to cover two operations which are sort of unique to Fusion, which is the thread and hole options. Some other software also have this, but I find the Fusion tool of threads and holes to be the most user friendly. And once I show it to you, you will understand why. But first of all, let's start with looking at some other options in the design workspace. Right. So as we recall from last time, we will create a new sketch. Okay. So I will select the sketch plane first, and then click on create sketch. Right. And then the first tool or the option in the design workspace that we'll cover is the revolve command. Let's see how to do that. So first, just to understand, let me create a new component first. I think that's better. So I am first going to create a cylinder, but using the extrude command or the command that we learned last week, right? So again, this is activated now. Looking at the origin, selecting the plane first, which is this one. I press on the C button to start the circle command, and then I'll just create a circle with say 100 mm diameter. And then, so this is a shortcut to bring up the press or pull command, which is to click on press the right mouse button, and then you can hover over different options. So I'll select the press pull, which is equivalent to the extrude command. And let's say the height is 200, height of extrusion. Okay, I press on OK. Now this is a simple method of creating a cylinder that we picked up last week as well. But if, as you would know from basic geometry, this is the axis of the cylinder. Now there's another way I can create the cylinder, which is to take a cross section of this cylinder and take half of it and then revolve it around the axis of the cylinder, right? So this command will help you create any axisymmetric component, right? Let me do that by creating another component. So do you see what happened? It created a component within a component. Now, why was that? Because this cylinder was activated, right? So any component can have subcomponents, right? So this is sort of an accidental learning, but I'll press Control Z now. So since this is activated now, when I create a new component, it will be a component which is the child of this component. So in the hierarchy, it will be present within this component, right? So for me to create a separate component, I need to activate this first, and then press on a new component. Right. So you can see now it's not within that component, and I'll hide this extruded cylinder for the time being. Right. So now we are trying to create a revolved cylinder. Right. Again, just like the previous command, we need to select a sketch plane first, but we will not select this one. We will select this one because this is the axis of the cylinder, and I need to revolve. Green, I think this is P positive Y axis. So the green axis is the axis of the cylinder, and to create a revolved cylinder, I need to sketch it on this plane. Sketch the the profile that is going to be revolved on this plane. So I create a sketch, right? And I click on the look at command so that it becomes planar, the view becomes planar. And then I look for the rectangle command because the cross section will be rectangle for a cylinder. Right. So our diameter was 100 so for the cylinder. So the radius will be 50. So I type in 50, and then I press enter. I have a rectangle which I'm going to revolve about this green axis. Okay. So I'll finish the sketch. I'll go to create and go to revolve. Okay. So the profile is the profile that is going to be revolved, and the axis about which it has to be revolved, which is you can either select the y-axis by zooming out, or you can select one edge of the rectangle itself, right? And then you have an option to limit the angle. Let's say I put in 90 degrees. So this is what you'll get. Okay. Now setting it 180, then you'll get half a cylinder, right? So I'll give it 360. Again, this is similar to the extrude command. Let's say I put in 60 degrees, and this is on one side. Now, if you want to do for two sides, you can have two options. Right? I can put in some other value. Let's say I put in 40 degrees. Okay. So you get 40 degrees revolution on the other side as well, right? And similar to the extrude command, there's an option for symmetric revolve as well. So this is 60 degree on each side of the cross section, right? For now, I'll leave it at 360, and this to one side, right? Right. So you can see over here, this is another cylinder, but created using a different command, right? Now, the utility of this function when you have a much more complex profile that is actually symmetric, right? So let me take another example, which will show you the utility of this tool. I leave it as a subcomponent for now. Again, I select the sketch plane first. I create a sketch. Okay. So now I'm going to draw a complex cross section. Let's say this is 100. I'm taking random dimensions, so you can take, if you're following along, you can take any dimension you want. So you can see now that I have created a irregular profile. Now I'll revolve this. Okay. Again, we'll select the edge of the rectangle, edge of the profile as the axis of revolution. And you can see I've got the component that I wanted. Okay. So now if I wanted to create this same thing using the extrude command, can anyone tell me how many extrude commands will I require? How many times, how many sketches and how many extrude commands will I have to do? Anyone?
Three sketches with three extrudes.
3 sketches and 3 extrudes.
Sorry. Prasun, can you be a bit louder?
3 sketches with 3 extrude commands.
Yes.
From the
So we'll need three, as Prasun said, three sketches and three extrude commands, and all that has been solved by using a single command of revolution, okay, or revolve command, right? So I think that's the utility. When you have an axisymmetric component, you can even create a spline curve and revolve it around an axis, which would not be possible to be created with just an extrude command, right? Okay. Moving on, let's look at the sweep command. Okay. So let me create another component. We'll create a component. So I'll first. So sweep in some sense is similar to revolve. So briefly, to understand what sweep does is it needs two things. One is the profile that you want to sweep, and second is the sweep pathway. So I basically take a cross section and I extrude it along a particular path, right? So let's say I take a circular cross section and I have a profile which is a circle, right? Now when I sweep it along that pathway, the circular pathway, then it will give me basically a donut shape, right? Do you understand the theoretical background? Or maybe once we go through it, it will be much more clear. Let's say I am first going to draw the profile that is required. So for the sake of simplicity, let's just take a circular profile, okay, with 50 mm diameter. Okay. So this it will require.
Take a call then. Tell me. Yeah.
Yes, sir.
Okay.
Hello.
Hmm.
Okay, so I'll draw the pathway that is required to sweep this profile. But one thing you have to keep in mind, the pathway has to be perpendicular to this profile pathway, sorry, the profile sketch. Okay, so if this is the sketch plane, this one, then the profile has to be on this plane, right? So I'll draw a random pathway so that we can see the utility of the tool. Okay, I've drawn a random spline for this. Okay. Okay, so let me bring up the sweep pathway. So sweep 2. So it asks for two things, profile and the pathway. Okay. So do you see the sweep that has come out? Okay. If there's a lag, then just wait for it. So now we just quickly look at the other options that are there. For our purposes, as a basic introduction, we stick to this single pathway. But you can also have a guide rail and a guided surface, right? What this basically does is that you'll have a surface that is going along this pathway, but not necessarily in sort of an offset of this pathway, right? And you want the sweep to not interfere with that surface that is already present. So you can select that surface as a guide surface, and it will not sweep, or it will not create material over there wherever that surface is present. Okay, and this distance is, as you can see over here, this does not have a unit, but what it basically refers to is the percentage of the distance of this pathway that is covered. So if I change this to 0.5, half of this spline will be swept. So let me just show that. Right. So it basically takes the entire length of the pathway and refers to that as 1. So if you want it to sweep till say 90% of the pathway, then you can change this to 0.9. No. Okay. I leave it to 1 for now. Again, taper angle is something similar to the extrude command. I think it's the easiest to just show it. Right. So it basically tapers it along the pathway, right, by that amount. This is mainly, if you're using a spline as the pathway, it's mainly used to create irregular surfaces or irregular shapes, right? So the twist command will not be sort of visible to you, the twist angle, because we are using a circular cross section. So let me just do this with a square cross section so that it's clear. And I'll delete this or maybe change it to construction for the time being. Is the screen visible now? So you can see, right? Let me change to 0 and then you can see. right? So basically, it will, let's say, oh sorry. So what it does is that it takes the final profile over here, that is should also be the same square, right? And then it twists it by 30 degrees, and the rest of the profile or the swept material is interpolated, right? And this orientation basically refers to the orientation of the cross section with respect to the pathway. Okay. So when it's perpendicular, the profile will always be perpendicular to the pathway. Right? I think it's much more clearer if you look at the icon they provided. Whereas in parallel, the profile will remain parallel. It will not, it won't sweep over here. It will throw an error because there's a sharp bend over here which prevents it from keeping the profile parallel to the original plane. Right? To address that, let's remove the sharp bend in the pathway. And we can even delete this point. Let's see if with this okay. So we've taken a fairly simple pathway. Let's see if we can create a parallel orientation for the profile. So this is perpendicular, and as you can see, because it's a perpendicular orientation, it keeps it perpendicular till this point. Whereas in parallel, it maintains the profile parallel to the original plane of the profile. Right? Any questions so far in the sweep option?
Yeah, hello.
Yeah.
While you're defining the pathway, should it always intersect the profile section?
Yes, it should always. So the pathway should always start from the profile plane, right? So what you're saying is basically if the profile was here in this, I'm looking at the top view. So if this was the plane of the profile and the pathway started from here, right? Or somewhere after that point,
Yeah,
right?
there's some offset to the profile. Yeah.
Yes, I think that should throw an error. Let's try it out. Let me edit the pathway and delete this coincident. Okay. Let's move it. It's not allowing me to select it. Okay, so now I moved it ahead of the profile. Let's see if it. Okay, it does throw an error. Actually, it throws a warning instead of an error. So, right, it gives us a slightly irregular shape. I think what I understand from this is it's just an offset of the profile that would have been created, right? But regardless of wherever you put the pathway, the sweep will start from the profile plane, right? Hello, Shankar.
Understood. Thank you.
Understood, right? So while it will not throw an error, it does give you a warning that it's better to keep the profile and the pathway. Sorry, the pathway should intersect the profile. Here it is not happening, but it still gives us a sweep body. But as you can see, it's basically an offset by this distance. Sweep from the profile plane. Okay. So let's just cancel that. Okay. Any other questions with regards to the sweep option? Okay. So one thing that you may have noticed in the sweep option is that you can only keep one cross section, right? I cannot have a square or a rectangle over here and a circular cross section at the end, right? So that sweep does not allow for that. What can be done is to use something known as a loft command. So that is another basic operation that is required from in regular CAD modeling. So let me cover that. I'll hide this again and create a new component. Right. So we want to take two different profiles, one being a square or a rectangle and another being a circle. Okay, so we'll do that now. So I select the sketch plane. I draw a rectangle, which will be the base. Let's put 50 or 50 by 25. Okay. Okay. So now I want to create so now I want to create a circle, which is, let's say, at some distance. The plane of the circle is at some distance from the plane of the rectangle. Okay. I basically want the circle somewhere over here. Okay. For that, I need to create a construction plane. Right. So since this one was made using the origin and the planes of the origin, but there's no origin over here, right? So if I want to create a plane which is at certain distance from the XZ plane, okay, so I need to create a construction plane. So if you go to the construction option, you will see a lot of options to create different types of construction geometry. Just like the construction line in the sketch, this is basically to help you create more complex geometries, right? So for now, we'll create what is known as an offset plane, which is nothing but creating a plane at a certain distance from another plane. So I'll take this plane as the base, and then I'll give some distance to it. Let's say I give 10 mm. Okay. So it creates a construction plane which is offset to the XZ plane, X and Z. So we were using the XZ plane, and I have now created a construction geometry which is an offset plane. Okay. So I'll select this plane and I'll create a sketch on it, which is, so you see the construction plane also has its own origin. Right. So I'll create a circle over here of 50 mm diameter. Well, let's take it smaller, 25 mm. Okay. Now I stop that sketch. Now we look at what the loft command allows us to do. So as you can see over here, it has basically joined the circle and the rectangle. Right. Let me make the circle smaller so that. Can you see? If this was done via sweep, we would either have a square, rectangle cross section or a circular cross section. But using the loft command, it allows us to select two different cross sections and join them, right? And again, just like the sweep option, we do have the option to select rails, which is basically the guiding pathway, or a center line. So if you want the loft to follow a particular pathway like this, or in some other direction, instead of just direct loft between these two cross sections, then you can select a center line also. Okay. And this option is basically to select these rails that allow you to control the profile or the body that is created. Right. I think for that we need to look at a few other geometries, and then we can come back to that in a later class. But this option is there for us to use. Right. So this is the outcome of the loft operation. Any questions so far? Okay, so I have basically covered the revolve, sweep, and loft along with extrude from the previous class. And these are the basic operations that you'll use in the design workspace. There are several others, but I think that probably requires some more playing around with the software from your end, and then only it is useful to cover that so that you understand the utilities of the other commands. So before I hand it over to Nawaz, I'll cover the thread and the whole command briefly. So before I move on to that, I'll just stop for questions if there are any. Otherwise, we'll start with the thread and whole command. Okay. So as I said, most of the times you'll have components that are going to mate with each other, and there are ways to create holes, which is basically to what Shankar did, to give a certain dimension to a circular cross section or a circle in the sketch. But if you already have a body and you know that you'll be using a certain type of fastener, let's say you know that you'll be using an M2 screw, right? Then you need to have certain diameters, certain diameter of the hole with respect to the standards that are present, the ISO standards that are present. So instead of looking it up online in their tables, Fusion has created an interactive tool that can help you create that. So let me just show you that. Right. So we'll just create a simple rectangle. Okay. And then I'll extrude it. Now let's say I need 4 fasteners at the 4 corners. Okay. So what I'll do is I'll first project the entire profile here, convert that to a construction geometry, because now I'm just trying to put the points where I want the holes. Okay, that is the only input required for the hole and thread command. Okay, so let me add the points. Okay, and I'll add a line here so that I can mirror the 2 points. Let's say we put 10 for each. So I'll mirror the 2 points above the line. Okay, so now I have the 4 points that I want the screws to go in. Okay, so first I'll create a hole for that. So this command is also present here in the create option. You can go down and find it over here, hole. Okay, so it allows you to select the 4 points. So I select the 4 points. Right. And right now the extent is distant by distance. So I can even reduce this. But since I want the holes to go through the entire rectangular block, I'll select the other side of the block as the extent of the extrusion. Okay. Now I need to select the hole type. There are 3 types available. One is the simple hole. The other is to make it a counter bore so that the head of the screw can fit in flush. And the third is countersink, right? So let's say I'm using Allen screws. Okay, so I'll go for a counter bore, and I want the screws to go in, or I can even select a thread option, right? So the hole will be a tapped one. Okay, and this is a simple hole. Let's say I select a clearance hole. Okay, so yeah, you can see it already has. There's some lag in the frame. So you can already see that they have a library of profiles already available. Right? For the most part, you can work with ISO or the anti-metric profiles. Okay. Socket head cap screw is basically Allen screws, and let me select, let's say M6. Right. So you can see it automatically generates the profile needed for it. Right. In the counter bore portion as well as the hole, and then the fit is a close, normal, or loose. This basically changes this diameter, this part, so that the diameter of the hole, if you want a loose fit, will be quite larger than the actual diameter of the screw. So the screw diameter will be 6 mm, and here you have 7 mm. If I choose the close fit, it will be 6.4. Right. So the screw will have less room to move. Right. So these are all sort of put in as a library and within this tool, and this eases your tasks a lot, because otherwise if you want to create a counter bore hole, you'll have to look for these dimensions from the standard ISO charts for screws, and then create 2 different extrusion commands, one for this and the next for the hole, right? So it makes the entire task very easy to do. I can even put in a tapped, let's say I put in a tapped screw. Again, you can select the class of the thread, the direction, and the pitch, the standard pitch. So let's say I put in the M65.5. Will create the same profile, right? So right now the thread is a cosmetic one. By cosmetic, it means that it only shows it as a image. But I can, sorry, keeps moving. But I can even model it, right? So which is actually cut it. I don't know if it's visible yet. Okay, I cannot see the OK command itself. Hidden by my taskbar. Sorry, I'll try and press enter and see if that comes. Yeah. So you can see it has given me the cut option over here. Hello?
Yes, we can hear you.
Okay, okay. I think there's some lag in the Fusion environment because it's an online tool. But are you able to see the 4 holes that have been created?
Yes.
Okay. So let me show you a cross-section view for that. So you can go in the inspect section over here and select this section analysis. So when you do that, you can select a plane and then look at the section view. Right. So this is the section view, and when you do that, this folder will come here. So you can create different section views. I can create a section plane in this direction. I can create it in this direction and then save them as different section views. And then you can switch between them. Right. So this is not a cut, but this is just to give you clarity in what has been created. This has not been actually cut from the part. Right. So you can see the thread has been modeled over here. So now if this part was 3D printed in a high resolution printer, this thread would also be printed, and then you can use an actual screw to tap it in, or actual screw to fasten it. Okay. Now coming to the last item that I wanted to cover, which is the component color cycling tool. So if you remember, we had discussed that the timeline has different colors associated with it for different components, which are matching the color of the component within the tree, this component tree. So to actually see the color on the component, you need to activate that option. So for the time being, I'll switch on the visibility of all components, and then we'll look at how to see them in their respective colors, which is this option under tools. Right? You go to tools and you switch on the component color cycling. So you can see that the color matches the color that is there on the timeline. So this is the blue one, which is the sweep example, which is in blue here as well as in the timeline. Okay. You can verify that. See, this is the revolved one, which is, yeah. Let me hide one of the two cylinders. This is the thread and hole example in purple, which is again purple here and purple here. Again, the loft example in red over here in red as well. Okay. So this basically helps you, visualize the large assembly very quickly, very easily. Otherwise, if everything is in the same color, it's very difficult to pick out edges and look at different components. So this is just from the point of view of usability. And the other thing that we looked at from the point of view of inspection was the section analysis. Well, yeah. And there are few other examples or tools as well that are, again, we need to cover in more detail in the later section. But I think for now, I'll hand it over to Nawaz, unless there are some questions. Any questions from anyone?
Hello.
Yeah, Shankar.
Sorry, will you be teaching the assembly option in later classes or any?
Sorry?
Will you be teaching the assembly option?
I would like to, but I'll have to. Yeah, I think we can cover that in a later class. I will pass on that feedback to sir. We could probably cover that in another class after Nawaz covers the sculpting module.
Sure. Okay. Thank you.
Okay. So what you can think of it is what I've covered so far is basically to create components and design. And sculpting is also another way to do that, but in a more free-form manner with more freedom. And then when you have, let's say, a free-form sculpted item and some items which are designed, then you can gradually move on to sculpting, because those are the two ways you can create something, and the assembly and joints will come in once you have created something, right? So I think rather than covering it today, let's look at the sculpting module, and then I'll ask for if you can have another slot for the assembly module. Okay. Any no other questions, right? So I'll request Nawaz to then take over and cover the sculpting module. Thank you. Nawaz, your voice is breaking up.
Hello.
Yeah.
How is it now?
This is much better.
Thanks, Deval. It was a very extensive coverage on CAD modeling and all the features. I actually learned so much, and so many ways to make your CAD modeling efficient. I could say so. It was really helpful. And okay, let me start with the Fusion form. So I'll give you an example of a project that I did during my course. So I'll share my screen. All right. Oh, can you guys see?
Yes, sir.
Yeah, Nawaz. Yeah, screen is visible.
1 minute. Just closed. Okay, so this is the typical example of form with which I worked on. As Deval said, not just form will make it useful. So as you see, there are so many other features that are created with something Deval has taught you. So these are simple extrudes and loft. You can see here, and everything all together makes it as a design and a part of a product. Okay, so this is basically a exploded view. I made it exploded. It's not a proper exploded view. I just placed it as it looks exploded. So that is where it is a project which involved mic and some sound processing. So it has to be attached onto a vehicle. I'm trying to take an image. So can you guys still see my screen?
Yeah, Nawaz.
Yes.
So these are the parts that that are 3D printed, that you see in the design are being 3D printed and processed, painted, and attached onto a car like this. So we wanted to make it look like a part of a car. And what we achieved successfully is it didn't look like something attached onto it. It looked like a part of a car itself. So this is a typical example where you have to use form, and to make it look whatever the way you want to make it to be. So show one by one. This is the middle part that you see here. Middle part. So all of these are 3D printed and painted. So okay. So let's jump into how we can do such things. So first is I'm opening a new file, and here you could see create form. So this is the thing that you're going to click and start making a form. Click it, and this is the workspace where you're going to work on a form. And first thing I would say is you should have a sketch of it's a plan of a form, how you're going to design something. So I have something like this. So front, side, and top view of something I plan to make it as a form. So what I'm going to do is I'm going to bring all of those and keep it in the respective planes as a reference, so that I can make the form having it as a reference. So as you see, if I hover over canvas, you can see the typical example of an image sketched behind and a car being designed. Okay, so this is a typical example. So I'm clicking it and I'm selecting it, insert from my computer. So I'm choosing this, open, and I'm placing it on a plane. So this is going to be my top plane. So I'm choosing it. You can move it, and you can have a rough estimate of the cube that you're going to work on. Say for example, this is showing all the dimension in X, Y, and Z dimensions. So you can set that up, and you could imagine the scale of your product or a component that you're designing. So I'm roughly keeping it like this and pressing OK. So top view is fixed, and I'm going to do two more of it. So open, placing it here. So roughly it is the side view and the top view. Okay. So one more image is running. Placed side and now the front view. Okay. So actually this has to be flipped. So you can flip the image also. doing it from the beginning. This is the image. Open. Flip horizontally. So you understood what I did? Hello, can you hear me?
Yeah, yes.
Yeah. Okay. So I basically placed all the images that I had as a reference, and one of the image didn't match. I have to flip it. I flipped it using this command in the insert canvas option, and I roughly, as this is a free form, you don't have to strictly maintain all the dimensions and all. As far as you do, it will be better. So uh, I'm roughly keeping the images as per my convenience and keep pressing OK. So this is what we are going to build. Now I'm going to, so these are various options from which you can create forms. That is box, plane, cylinder, sphere, torus, quad ball, pipe, face, extrude, and everything. So same loft and everything is also here, but you have more control uh, over each and every faces of a loft. You can increase the, as this image shows, you can increase the number of partitions in between the loft face and modify it as much as you want. So you'll understand once I show one example. So I'm going to start this by this select and so after clicking you draw a rectangle. So you first what I did is I made a box with T-spline curves as shown in this images. Okay, the number of T-spline curves can also be defined here. Say this handle here defines how many number of T-spline curves you want. So there is only one T-spline curve on this box. If you want more, there are more getting increased. You can do how much ever you want and control it whatever way you want. So what my personal advice is, you keep it as low as possible and use it wisely. So you should keep as minimal T-spline curves as possible, only for the features that you need. So uh, what I'll do, I'll basically, so this is how the entire form works. So you have arrows on X, Y, and Z directions in each and everything that you select in the form. So you can click this handle and pull it. So this is very easy compared to any other free form that you could work on. Everything is simplified with the handles on each axis. So I can pull this handle to make it this big. Okay. So what I have to do is I'll have to roughly make a box and some number of T-spline curves that I need in them, and make a box first. So you can define dimensions here as well, number of faces, width, and everything. But if you really need it, you can give it here. But most of the times, as you are doing a free form, you will be driven by this image that is in the background. So press OK. Want to move this. So if I double click a face, the entire box will get selected, the entire surface will get selected. And if I double click a part of a curve, the entire curve will get selected. Okay, so this is how it works. Selecting every time you want to do edit a form, you'll have to click this handle, edit form. I'm placing it where I wanted with reference to the so, okay. So now one more thing very important in the form is multiplying the curves. So you select this curve, edit form. Okay, and now what you could do is, this is to show you how things work. I'll not spoil this. Rather, I would go to this example and show you how to work with different options in form. So okay, so I wanted to extend this surface similar to this. Like I want more curves and surfaces here. So what should I do? I should click, and after clicking edit form, press Alt and drag it to whatever direction you want. So see this. I am pressing Alt and dragging this, so I'm getting this multiplied. You can do again, press Alt and do this. If you don't press Alt and just click and drag it, you will just stretch it. Understood? So, and as I had put, as I had applied mirror over here, it is getting replicated on the other side as well. So we'll go into detail of how to make symmetry on. It's here where you'll have to select one part and a line, and it makes a symmetry. So going back, how to make this shape. Clicking this edit form, control plus click. So usual controls are like same as Windows. You press control and click the near click. You can select multiple items. Basically, I see this surface slightly moved a bit behind, so I'm doing it. And the entire height of the cube should be less. Clicking control and selecting all the surfaces I want. And click and drag this, make it small. Okay. Even click a point and move it with this handle. This is planar handles. These are axis handles. So these three will move in XY plane. Sorry, this planar handle will move in XY plane, and this planar handle will move in YZ plane like this, and this planar handle will move in X and Z plane. Okay. So these handles, what it will do, you can make it bigger in the respective planes. This corner thing that you're seeing, make it bigger or smaller with this. So it's all intuitive. You can just understand it by seeing. So this handle expands only in that axis, and this handle will do in this axis, and this will do in this axis. So this arrows basically will move that in that axis. These are to minimize and maximize, basically scaling in that axis. And these are to move in that plane, and these are to move in that axis. Okay. So now I'm going to do this small feature that is there. So press Alt and move it. So you get it replicated, and I want it smaller. So I press Alt. I'm now pressing Alt and clicking this handle is becoming bigger. So you got it what I did. So if I keep pressing Alt and pressing this handle, I keep creating multiplication of that selections towards inside, which is getting minimized. So Alt and all this handles also play a major role. If you want if you want the surface replicated smaller, scaled down, then you'll have to press this handle with whatever axis or plane you want, the respective handles of the respective plane, and you can click and drag pressing the Alt button. Go back from the experimentation to actually making. So I made a smaller version of it, and I'm going to lift it as I wanted it. As I said, it should be maintained as minimum as possible, the lines and surfaces, so that you don't make it clumsy. You can either push and pull surfaces or curves. You can do both to match your required profile. And okay, roughly we made that, and go to this surface. This need to be so pressing Alt and lifting it up. Okay, so surface, so again an Alt. So this is one more handle with which you can rotate whatever you want. So I'm holding this and rotating it. Again, I'm pressing Alt and stretching it. So as we see, it is somewhere like this. So I'm pressing Alt and this. So as I pressed Alt, you can see a new surface split that has been created. This is how roughly you can make up whatever you want. So until I'll pause it here. So you guys have any questions? Excuse me.
Yeah, hello.
Yeah.
I couldn't understand the difference between pressing Alt and without doing it with Alt.
Okay, I'll show it again. So back. 1 minute. I think I closed Fusion. No, see. Okay. So the difference between alt and the normal, right? So here I'm doing it without pressing alt. It's moving like this. Okay. Now, if I press alt, it'll do. And I left it once. Again, I'm pressing alt and doing it. You got the difference? Okay.
I can understand.
You can see the number of surfaces getting created. Okay, if you press alt and do, and so here alt, see it is a new surface that is being pulled. Okay, and there are supporting surfaces that are being created. Okay, now I'm not pressing alt, I'm just dragging it, so it is moving. Now I'm pressing alt and doing, you can see a new surface that is being created, right? This new T-spline curve and these surfaces are being created. Okay. So even better example, I'll show it here, where you can do it with anything, not just with surface, you can do it with even this line. Okay, here in editing form, edit form, here I'm moving the surface, right? I'm just moving the surface like this. Now I'm pressing alt and doing the same. Got it? You understood, Shankar, what I did?
Yes.
Okay. Any other questions? Like any very basic question, how to start or something, don't hesitate. Like I went quite fast, or you can catch up or something, you can ask me. Any questions? You guys have Fusion there in your PC?
Yes, sir, we have.
Okay. Can you do this practice side by side, and if you find any problem or something, you can ask me. As I do, you also try something alongside. Okay. Okay, so after this, to make a part like this, you would have to make it as a solid part. So once you did this, you can click finish form. Okay, this gets simplified on its own. So this is out of the form workspace. So this becomes as a normal solid part. Okay, if you want to go back and edit, you'll have to edit it again. Like you can click here and go edit this feature. So as I said, you should keep um, the curves, T-spline curves, as minimal as possible. One thing you can do is you can actually delete unwanted curves by pressing delete button straight away. So basically this curve is doing nothing. So this is not very much designed. It just stays in between two curves as a interconnection. So we can delete it, or if you want some features, you can use that. For that, I think you should always go out of this edit uh, setup and go back and delete it. You can select anything and delete. So a void space that has been created here as I deleted one surface. So again, if I go back, edit form, I can still edit and work on this. So this becomes a new point where you can click and drag like this, this, this. So I'll take you through symmetry. Symmetry you can create while doing itself. Like for example, here you have an option for symmetry. So you can select mirror. Here it is slightly confusing, but it is straightforward. Height, length, and width symmetry. So here and here. So you could see three green lines with which the sides are going to be mirrored. So this, now I edit this form and hide this. This is a new form that I created. Now you can edit this form, and whatever you do it here, it will get mirrored on all the sides. Okay. Just for better understanding of alt, I'll show an example of pressing alt as well. Why? Okay. This is how symmetry works. If you deploy it right in the beginning of creation of any form or cylinder or anything, so you can experiment on this. Okay. Now I show an example of creating a surface, simple surface. So is a rectangle, and even here you will have this handles for how many control lines you want. So you can click select as much as you want. Yes, if I move in the plus direction, it is increasing. If I move in the minus direction, it is decreasing. And these handles are to make it how much ever you want in your we want it extended in X and Y directions. Okay, you create, and even here you can apply mirror, length mirror, width mirror. So whatever I do here will appear there. And now if I click edit form, it gets mirrored in all the direction. One more way to give symmetry is by using this option. So I'm creating a rough surface. You can actually, if you don't want a edge, you can click this point and press delete. Click this point, press delete. Okay. Delete button, just a keypad button will work. And now you can edit this form. I'm pressing Alt and in this. Okay. Now I want this surface to be mirrored about this. I want to make it symmetric. Now I select symmetry. I better use this mirror. Mirror internal, I can do either select this line and make this and this as mirror, or I can duplicate it. So clicking this mirror and duplicate. Okay, duplicate T-spline body, select T-spline body, select mirror plane. I'm selecting this plane and this get mirrored. If you want to weld, this gets merged, so it becomes a single part. If I don't weld, it becomes a different part. So for example, before making a symmetry, I'll edit this point, form, slightly make it like this. Okay. Now I'm going to do the same symmetry, duplicate, select the body, select the plane, and now I'm pressing weld. So this is how it welds both of the parts together, but there is a hole. But what if I don't want a hole? Okay, I'll show one example here, and Control Z, I'll go back and show how to merge it completely with different options. So with this, I can actually this, I'm pressing Alt and edit form. I'm pressing Alt and doing this. So you saw the difference between pressing Alt and not pressing the Alt. This is a very good example where there is only one line. I want to develop a surface along that line. So I'm pressing Alt and holding this. I roughly bring it until here. And press OK. Now what I'm going to do is I'm going to mirror, duplicate the entire thing, select, press OK. And now this is so I want a plane just beside this. So what I'm going to do is I'm going to construct a plane on this surface. So you get all this in construct option. You can create construct planes, offset planes. I think they would have covered. Offset to this. Here. So this is the time when you should switch off perspective display. So you should switch off perspective display so that you don't get confused here. But I'm doing it. Okay. I'll mirror it. Duplicate, mirror plane. Got it. Now I weld it. I'm not going to weld it, leaving it as such. So yes. No. So I showed you guys how to make a circular symmetric thing, this four-way circular symmetric thing, but now I made it that time I showed you in the plane and in a box. Now I made a plane and it is almost going to be a box with the same circular mirror. So I'm one step before making it as a complete box. So how I'm going to make it as a box is using this multiple options: merge, bridge, and weld. So weld is different, bridge is different, merge is different. We'll see how they are doing. So add one group and group 2. Select. So 2 of it are selected. They are capable of getting merged. Pressed OK. It got merged. So two T-spline curves get uh, together as a single T-spline curve with the merge option. What happens with weld or bridge is Control Z the same and bridge. side 1, side 2, and you can follow a curve. Okay, so merge, you can select two surfaces, and that in this option it automatically followed a curve, the same curve, and merged a surface with extra faces. And let's see how weld works. Modify weld vertices. So you guys would have seen how weld works in while mirroring itself. So some reason it's not getting selected. Mirror duplicate. So mirror plane is this, and if I click weld, so actually this surface is for some reason cannot be welded. I'll show some other example where you can weld it. So this is a typical example where you have to merge it. So group 2. This becomes a center line with which all the modification done on the left will reflect on the right. Here I can show a build example. Okay. Mm. So weld is same as merging, but the difference is you select point by point uh, and only a part of it, whereas merge selects all the curve all together and merges as a single T-spline curve. So if I want to leave it as such surface, I can leave it using weld, and there's one more option to fill hole. So that hole is getting filled. I select hole. Okay, one more thing, I'll show you how crease works. You can select a line like this and crease it. So I want this line to be a sharp line. You can select crease option and make it look like this. Okay. So you can uncrease whatever you creased. So these surfaces has gotten uncreased. So any questions until here?
Yeah, hello.
Any questions, guys?
Hello.
Yeah.
Yeah. While creating a form, will it be a solid or a surface actually?
It will be a surface. After you finish it, you can once you thicken it, we'll go to those details. Once you thicken it, it becomes a solid. I'll show you. So this is a new feature where you thicken it in the in this form workspace itself. I would rather show there as an example here. Okay. Oh. So some 4 mm thick. Okay. From a curve, this is being converted to a solid thing, and after this you can go back to other workspace. To convert. So these things will happen once you do this thicken option. So some T-splines will fail, for example here. So you can go back, edit form, and somewhere you'll have to adjust and see where these T-spline is failing, and then you go back to design. There it becomes a solid, complete solid part where you cannot edit it, and but you can add, subtract all this Boolean functions you can do on that and make it like this. Once you successfully export, you successfully come from form to normal design workspace, it becomes like this and a solid part. Am I right, Deval? Does work? It works like this, right?
Yeah, no, that's okay.
Any other questions? So I'll stop it here. I want you guys to the same way you did exercise last time. You have to do exercise here in form. Like it is similar to what I showed here with 3 images as a canvas, and you try to replicate it. So you draw a surface or something, or you can take it if you are a MDes student. I would prefer you to do that. You would render a surface as complex as possible in Photoshop or something, in Sketchbook or something. Bring it here, try to define it better than this, front, left, and top. Put it here uh, in the planes and start playing with the sculpting. Okay, and if you are not an MD students, you're not well versed with sketching and rendering, what you could do is take a form from Pinterest or somewhere and do this exercise. So I had given you a glimpse on half of it. You can also explore by doing it, because each of it will have unique applications. So you can go for online tutorials and have a look. And once you do them, like today we did, like today Shankar did, you guys will come and explain how you did it and which functions were, which options here were useful for you to make them possible. Is that okay?
Yeah.
So Deval, I have to leave. I have one meeting at 4:15. Deval, are you there? Okay, guys. Let Deval come back and continue. Deval, are you there? One minute.
Hello? Can you hear me?
Yeah, Deval, I can hear you. So Deval, if you have something to continue, you can continue.
Yeah,
I'm
Nawaz,
sorry.
I don't have anything to continue now. I'll have to discuss with sir what else he wants us to cover.
Okay. Okay, then we'll close it here. Sir told me to do for an hour, and I think he'll join back. What should we do now? We'll leave it here, or
let me just quickly call sir and find out if he has it.
Yeah, anyone.
Sorry.
I finished the first module of giving introduction, and they let them do an exercise. After that, they'll come back and we'll go in depth in all the commands and options.
Okay, I think then we can close then. Okay.
Ma'am.
Yeah, Kitur, you are done?
Yes, ma'am. For this session, I'm done.
Okay.
Let them
right.
do this assignment.
Okay. What is that?
Yeah, so the assignment is they have to and present again. I'm sharing, right? So assignment is they have to put images of some renders like this on Fusion and make the form like this.
Okay. Okay, right. So next Wednesday would be the deadline. Okay. So next Wednesday, 2 o'clock.
And I would suggest to explore all the features that are there to make their form possible. Okay. And when any new features there that they had made use of, because everything will come in when different forms are explored. So let them explore different forms and make use of the features, and let themselves present what unique they used out of these features and made it possible.
Okay. So you have uploaded this image in Fusion, right?
Should we do the same image or
anything? So, but it should be complex, So sketch to basically they can do the sketches of 3 sites and then do a
So they can come up with their own form as a sketch on orthographic projection like this, and then they can.
Okay.
Yeah.
Okay. So I'll create this as assignment, and then next week 2 o'clock. Others submission is also open. So everybody, there's another assignment sir gave in class for in March. So please upload that also in this. Okay, and then last week's assignment, please submit that also by 7 o'clock. Okay. So late submission there'll be a penalty. Right. So this one's deadline would be next lab class beginning 2 o'clock. Okay.
Okay.
Should end or should we wait for, is Deval calling you?
No, Kumari, I also don't have.
Yes, yeah.
Yeah, I have also finished my portion.
Yeah. Okay then. Yeah. Bye.
Okay. Thanks.
Bye.